Good morning, students. This is our work for Friday, October 2nd. We are going to make our own Sesame Street Muppet character today. So you're going to create your own new Sesamus Muppetis character today. So the first thing that you're going to do is choose two of the Muppet characters that we have studied in class. You can choose any two of those that you want. These instructions, by the way, are in Google Classroom, but I'm going to go through them with this video so that you can see exactly what it is that we're doing in class today. So you're going to choose two Muppet characters that we have studied in class. It doesn't matter which two. We've got Grover, Abby, Zoe, Honker, Telly, and Elmo. So you can choose any of those two. Um, Choose a male character and a female character. Yesterday, some of the students asked, could you use honker as female instead of male? If you want to do that, you can, because the honkers are actually kind of a class of Muppets. So if you want to say, well, here's a female honker, go for it. That's perfectly fine. I don't mind if you do that. So you can choose two characters that you want to choose, and you are going to draw their gene maps. So this is the basic idea of what all of the gene maps will start off looking like. I'm going to use Abby and Grover as an example here because we've already done a cross between them, and I just want to give you a good example of what class is going to look like today. So you're going to draw your gene map. So here's the original cell for Abby. Here's her chromosome 1. Here's her chromosome 2 pair. So chromosome 1 pair, chromosome 2 pair, and the sex chromosome. So she would have an X and another X. Same thing here for Grover. I've got chromosome 1, chromosome 2 pair, chromosome 1 pair, chromosome 2 pair. He's going to have an X and a Y. So let me go ahead and show that here's an X, and we're going to have an X and a Y. Okay? So then I'm going to decide which of these is heads or which ones is tails. I'm going to basically do this by chance. And so I'm going to use a quarter here. And because I'm using different colors, that's what I'm going to go with. And I'm going to say um, over here for the flip, we've got heads and we've got tails. Okay, so I've put several things in here for you. I went ahead and wrote in the gene map for Abby and the gene map for Grover. This is what a gene map looks like. It's a little bit messy. If I were to go back and do this over again, I would probably draw these circles quite a bit larger because I'm trying to fit three chromosome pairs in here. I also wrote over here to the side for you so that you could see um, what color I'm going to use, what color of chromosome I'm going to say goes with heads, and what color of chromosome I'm going to say goes with tails. So I'm just going to flip to make the egg for Abby, and I'm going to flip also to make the sperm for Grover. So we're doing meiosis here without going through the whole entire process. We're going to shorten this out and just take a look at what one of the gametes might look like. So I'm going to start here with Abby. Let me flip a coin. Okay, I've got tails. So for chromosome 1, I'm going to go with my purple color. So I'm going to put that in. For chromosome 2, I've got tails as well. So that's going to be my maroon color. And then for the sex chromosome, that's heads. And so that's going to be the black mark. And so that's an X chromosome here. Abby's going to have to give an X chromosome, but which X chromosome is the issue. Okay, now I'm going to do the same thing for Grover. Flip the coin. Whoops. Bring that back. Flip the coin. So I've got tails for the first one. So that's purple. And I've got heads for the second one. So that's going to be green or the teal color. And then for the third one, tails. So that's going to be the red. That's going to be the Y chromosome. Okay, so now I'm going to go ahead and write in the gene map as it would look for each of these two uh, gametes. Okay, so now I've got my gene maps drawn in for the sex chromosomes. So I've just shown which chromosome is going to be passed on to the offspring. And so the last thing that I'm going to do is I'm going to draw the fertilized egg. So here we have our new baby Muppet. So this is a combination. This baby Muppet is a combination of the egg cell from Abby and the sperm cell from Grover. And so we can see at this point what the combinations are. This again is our chromosome 1. This set over here is for chromosome 2, and these down here are the sex chromosomes. Okay, take just a second, and if you want to go ahead and do this process for your two choices for Muppets. Okay, so what I'm going to do now is take you through the process of figuring out the genotypes and the phenotypes for our new Muppet here. So for the eyes, the baby has a little e and a little e, so a recessive allele and a recessive allele. So the genotype is homozygous recessive. For the nose, that's a capital P and a capital P, so homozygous dominant. For the lips, a capital M and a little m, so heterozygous. For body, a B allele and an O allele. And then for hair, we would say X, H, Y. And so this is male. So we got a baby boy here. And then we can figure out what this baby looks like. So this this genotype here is the recessive genotype, and so this will give us a baby with flat eyes. The nose, this is heterozygous dominant, so baby's going to have pink nose. The lips are heterozygous, and so this is incomplete dominance, so we'll have red for the lips. The body, we've got multiple alleles and incomplete dominance together. So this gives us magenta. And then the hair, so the baby has hair and the baby is male. So at this point in time, you would take these characteristics and you would take maybe a sheet of plain white paper if you want to use that, or a sheet of in your notebook here, and you're going to draw Abby and Grover, or you're going to choose two other parents probably. So choose two parents. You're going to draw your two parents, and then when you've finished with your two parents, and you can draw your baby. So to recap, you are going to choose two parents. You're going to write in their gene map. So you're going to draw in their gene map. You're going to flip a coin, decide what's going to be heads and what's going to be tails, which chromosome. So like make your chromosome pairs in two different colors if you possibly can. So make your chromosome pairs in two different colors, and when you do that, then you can choose which color is going to be for heads, which color is going to be for tails. And then go ahead and flip the coin. You can use a coin flip on your phone or on your Chromebook. They have apps where you can flip a coin. And then once you have flipped those coins and figured out which color chromosome goes into here, go ahead and write in the alleles, the forms of the gene that are found on that chromosome. So here's the purple one that was passed on because I flipped tails for this one. Here's the purple one up here. And so I can just bring that information down. So do that for the egg cell from your female, do that for the sperm cell from your male, and then combine them. So draw a nice circle, bring in the chromosome ones, bring in the chromosome twos, and then bring in the sex chromosomes. When you've finished writing all of that in, then go ahead and figure out the genotype and the phenotype of your new baby. Once you have finished with doing all of the work, then you're going to draw these two. So, or these three actually. You're going to draw the mom that you picked, you're going to draw the dad that you picked, and you're going to draw the baby. If you want to use a draw program on your Chromebook or computer, you are welcome to do that. If you want to draw in your notebook or on a piece of white paper, you can do that as well. But what you will need to do is by the time we're finished with this will be which will be the Monday after fall break, you will need to have all of this done. You won't complete all of this in one class period today because you also have a quiz to take over vocabulary, but you'll probably get through a pretty good bit of this work today. Okay? Um, Hope everybody's doing well, and I'll see you soon.